Okay, guys, I'm just gonna re-record this real quick. I probably thought I had my AirPods mic on, and it was probably on the computer, so that's why the sound probably didn't record good. All right, so the first situation when it comes to segments and circles is going to be when we have two chords. When we have two chords, you should know what a chord is at this point. This is what it's going to look like: one chord and the second chord. Um, they don't have to pass through the center, obviously, nothing special. When we have two chords, one of the chords will be split into sections A, B, and the other chord will be split into sections C, D. And simply, this property is telling us that if we have a circle and we have two chords, then the product of the two parts are equal. So A times B equals C times D. The key thing there is just not to mix it up. You can't say AC and BB. It has to be parts from the same specific chord. All right, so I have a couple of examples using this property here. We'll do two of them. We'll do the first and the last. The ones in the middle, you should be pretty capable of doing on your own. I'll pause it for a second after the first one. I'll give you guys some time to try the two and the three, and then I'll go on to four. All right, so for the first one here, if we're applying the rule, again, these are our two chords and they're intersecting. So for the red chord, it's going to be 6 times x. Oops. It's going to be 6 times x. Then for the other chord, it's going to be, the parts are 9 and 2. So it's going to be just 9 times 2. So 9 times 2. So we end up with 6x equals 18. And then we get x equals 3 when we solve that. Hopefully that was pretty straightforward. Again, I'm going to pause it for a minute. You guys try the next two. I would pause it for a minute, try the next two before you see the answer. All right, so 2 and 3, there are the answers. And now we're going to look at 4. The 4 is like, it's the same rule, but it's a little bit trickier. This will pretty much be as tricky as this could get when it comes to the two chords. Now, for this segment here, I didn't write anything, so let's try that again. For that segment there, it's just going to be 6 times 8, clear enough. And now the issue is the other segment. Now, first of all, this extra 8 over here is not part of either of the two chords that are intersecting. This is a radius. Now, the purpose of them giving you that is because this is a diameter. And we should know that a diameter is equal to 2r. So therefore, the diameter here is going to be 16 since the radius was 8. All right. So how does that help you? That helps you because now we know that the entire chord here is 16. So I'm just going to cross this out because this is now useless to us. I don't want you to get confused. So the way we're going to solve this problem is we don't know how this 16, we do know that the red segment is 16, but we don't know how it's being split up. We don't know if it's 2 and 14. We don't know if it's 3 and 13. We have no idea how it's being split. So the way we're going to approach this is we're going to say, we already know that this is x for this part over here. So that's that part. And then the other piece, I'll use a different color here. The other piece from here down, thicker marker, is going to be the rest of the 16. So the way you would write that would be as 16 minus x. And again, let me try to clarify. So if I came in and said that this was, different color, if I came in and said that this was 7, then the rest of this would have to be 9 because 7 plus 9 gives you the 16, and we know the whole thing is 16. If I came in and said this was 4, then it would be 4 and 12, etc. So that's kind of the relationship that they have. So we're doing that same idea, but since we don't know what x is, it's just x and 16 minus x. Anyway, let's go ahead and solve this. Now, the solving of this would be more of something I would give to honors because it is going to end up being a quadratic. But for the regular, still know the concept. I'll probably, put the concept here, just not with as elevated a solving process. All right, and then to solve this, we want to get the x squared and everything on the same side. I'm going to move this and I'm going to move this. The reason I'm going to do that is because I want my x squared positive. So it'll end up being x squared minus 16x plus 48 equals 0. And then we would have to factor this to solve it. There's some other options. Again, for regular, no worries about solving of this. It would be x minus 12, x minus 4 equals 0. My two answers would end up being x equals 12 or 4. Now remember, in quadratics, in situations like this, not every answer will work. So let's check it. And I'm going to say the only answer here that'll end up working is the x equals 12. Excuse me. I'm sorry. The only answer that will end up working is the x equals 4, not the x equals 12. And the reason for that is going to be because we know that the radius was only 8. So it's no way that this over here could be 12. So it wouldn't make any sense. So it has to be 4. All right, next rule is going to be when there's two secants. When there's two secants, let me give you a visual of this. This is how this will look. And the outside part, we'll say is A. And then this inside part is B. And then we have C, and then D. Now, with two secants, again, they pass through the circle, and it has 2 points on the circle. Now, the property here, the best way to think about this when it comes to this is that this is the outside, and then this is the whole. So, out is like the outside part of the secant. So it's outside times the whole segment. By the whole segment, it's A plus B, so it's going all the way across. So it's this whole entire thing. And then the other one is the same. It's the outside part, which is C, this small part, and then times the whole. The whole is when you add C plus D. So again, that's the way I would think about these. And let's see the examples I have. I think I have 3 here. I'll do the first 2. The second one's a little different, so I want you to see that one. All right, so for this one, outside times the whole, so it'll be 5 times 5 plus 7. I'll just write the whole thing out right now. Obviously, you guys can skip steps, not to write so much. So it'll be 4, and then the whole is going to be 4 plus y. And then we will go ahead and solve this. It'll be 5 times 12 equals, this you would distribute. You would have 16 plus 4y. 60 equals. I'm about to write 40, 34 is 44. 44. And you end up with y equals, I don't know why I wrote a b, sorry. Y equals 11. All right, next example. For this one, sorry for yawning. We have the outside times the whole. So the outside is z. The whole is z plus z. Let me put my little line in here to make it clear. And then we have 4, the outside, times the whole, which is 4 plus 5. All right, and then let's do that math. Alrighty, so z plus z is 2z, so it's z times 2z equals 4 times 9. So this one we multiply into being 2z squared. Z times z is z squared equals 36. Divided by 2, we get z squared equals 18. And excuse me, at this point, you could square root it. In radical form, it would be z equals 3 root 2. And the actual square root of 18, if you got the decimal, is 4.2. All right. Next example, I'll do this one. This one will be more of the honors type for solving because it'll be a quadratic. It'll be z times z plus 8 equals 3 times, excuse me, when I add that together, I get 16. Just want to save some time. All right, so z squared equals 48. We'll subtract the 48 and minus 48 equals 0. This would be x minus 12 and x plus 4 for factoring. And my answers here would be x equals 12 or x equals negative 4. And in that case, I'm sorry, this is a z. I tend to always switch it to the x's by habit. I'm sorry. So it's z equals 12 or z equals negative 4. And it can't be a negative segment out here. So I would go with 12 for my answer. All right, and now the last rule is going to be when we have a tangent and a secant. So what that's going to look like is going to be the following: secant, tangent. All right, so the secant is just like before, it's going to have an outside part and an inside part. And just like before, it's going to be the outside that goes first. So in this case, the outside would be A. Outside, I'm just going to write it in words. So the outside times the whole equals the tangent squared. So you can just say the tan squared. I don't know if that'll confuse you. Just write the c squared, whatever. But basically, again, it's always outside times whole. Excuse me. I'm sorry. And this is the tangent here, the c. So that's the one that gets squared. Since the tangent only has one part, it's just squared. It doesn't have an a and a b. All right, so let's look at the few examples that I have here. And then we will move on to the next slide. On the next slide, I just have some mixed examples. So I'm pretty much gonna like just well, actually, let me just do the slide first and I'll talk about it. So for this one, x, here is the tangent. So it's gonna be the thing that's squared. So it's gonna be x squared. Sorry. It's gonna be x squared equals for the outside times the whole. And the whole here is 4 plus 5, so 9. We have x squared equals 36, and we get x equals 6. We take the square root. All right, next example. For this one, this is our, excuse me, tangent, so that's the one that's squared. 10 squared equals, outside is y, a whole is going to be y plus 21. Can't write that as, one number because it's a constant, I'm sorry, variable and a constant. So it's going to be 100 equals y squared plus 21y. Now to continue solving it, you want everything on one side. So I'm going to move the 100. Excuse me. I'll have 0 equals y squared plus 21y minus 100. All right, I'm going to factor that to solve. It'll be y plus 25, y minus 4 equals 0. You end up with y equals negative 25 and y equals 4. Again, you can't have a negative segment, so our answer here would have to be the y equals 4. Again, this would be more of an honors solving. And then the last problem here, doesn't matter when you put first. I tend to put the tangent first. So we'll do 8 squared here, which is 64. Excuse me. Equals the outside, which is 4, times the whole. So this time it's going to be 4 plus z. So it'll be 64 equals 16 plus 4z, distributing. We end up with When we subtract the 16, 48 equals 4z, and therefore you're going to get 12. All right. On this next slide, here are all of the problems. I'm going to do, excuse me, maybe 2 or 3 of them in detail, and then I'll just put the answers for the other ones. I'm going to pause it at this time. You guys try them. And then, I would pause it at this time. You guys give them a try. And then you could watch and see the examples, see if you needed any help or you were capable of doing it on your own. All right, so I'll start with the first one here. For this one, it's going to be the one we just did, a tangent and a secant. So it's going to be 8 squared equals x times x plus 3x. I'll write it out to be more thorough here. 64 equals x times 4x. Excuse me. 64 equals 4x squared. All right, I would divide by 4. End up with 16 equals 4x, which are x squared. And I square root my answer is 4. All right, the second one, for this one, there's actually like 2 separate things you need to do. I'm going to first do x just because it's alphabetical. And when I'm finding x, I'm just going to basically ignore that other segment. You can only do it like 1 variable at a time. So at first I would focus on what we have here. When we focus on this is 2 secant. So when it's 2 secant, it's the outside times the whole. So it's going to be 8 the outside times the whole, and the whole will be 8 plus x. For the other secant, it's going to be 9 the outside times the whole, which is 9 plus 16. All right, and then we would go ahead and do that, and it's going to be 64. 64 plus 8x equals, this is 25. 9 times 25 is 225. All right. Now I'm going to subtract the 64. 8x equals 225 minus 64 is 161. Then I'm going to divide by 8. I get 20.125 for x. All right. Now, if you went on to the next problem, remember you're too early. We still got to get y. So to get y, what I'm going to do is ignore this middle segment with the x and the 8. Now I'm just going to focus on this y over here and the secant. So when I'm looking at this, I have a tangent and a secant. So it's going to be y squared, because the tangent is squared, equals the outside times the whole. So it's going to be 9 times 25 again. So it's y squared equals 225. Square root y is 15. All right, and I'll do this next one with the 3x just to show you what to do with that. And then the other ones I'll just post the answers to. Again, make sure you guys can do these on your own. All right, so this is the 2 chord situation. So it's going to be 6 times 3x equals 9 times 17. So that's 18x equals 153. So just divide that by 18. And my answer is 8.5 here. All right, I'm going to pause it, put up my other answers, and you guys should be done. All right, so here are my last answers, and you're done with segments and circles.